We should get started since it's time. This is Privacy Pass. Your chairs are Joe Salloway and Ben Schwartz. If I can get my slides to advance here. By this time on Friday, you should probably all be familiar with the Know Well, which kind of describes your obligations with respect to contribution and participation within the IETF. I'll leave it up here for a brief second more. If you're not familiar with it, you can always go to the IETF website and look at it. Okay, we have a minute taker. We can monitor Jabber, but if there's important points raised in Jabber, somebody can bring those to the mic if chairs don't get to it. We have no blue sheets to sign because this is a virtual meeting. When you're speaking, please state your name so the note taker can easily capture that information, and always keep the discussions professional. On the agenda today, we have a presentation on the document update, a summary from the second anonymous credentials meeting, and then a section on adding public metadata to the Privacy Pass. Does anybody have anything that they would like to add or update on this agenda? Chris?
Yeah, if possible, could we swap the last two? I think the public metadata is more important than the meeting update, and in the rare case that we run out of time, it'd be better, I think, if we spent the time on that.
I'm okay with that. Are there any objections? Okay, we'll switch those two. All right, so for the presenters, I'm happy to run the slides. I have it set up here, but then you have to kind of tell me to advance the slides. I don't charge for that service, but if you would prefer to run your slides yourself, then we can do that as well. So I think, Stephen, you're first up. Would you like me to run the slides for you?
I can just run them myself if it's
okay.
Or easy enough.
That's fine.
Okay, ready for the first one. So I'm Stephen. I'm going to quickly go over the current status of the various Privacy Pass documents, open issues, and what the next steps are based on our charter. As a reminder, the Privacy Pass drafts are split up into three major drafts. There's the protocol draft, which talks about the cryptographic primitives and the methods that we expose. There's the architecture doc that talks more about the ecosystem and is built on top of the protocol draft. And then there's a sample HTTP API draft, which is the HTTP implementation of the architecture. And all of these is built on top of various crypto primitives. Currently, the VOPRF draft is the main one we support, though there's been some discussion about other constructions that could possibly fit into this whole. So since last meeting, we've had a couple of closed issues. The major one was adding redemption context based on the presentation at IETF111, which basically adds to the architecture doc some discussion of how to view privacy boundaries during redemption time to allow for more issuers to be in the ecosystem. And then there's also been a minor fix to some of the TLS syntax in the protocol draft. In terms of the open issues for the protocol, the one major open issue is how to refactor the flow to better support how the VOPRF inputs and outputs have been updated in the CFRG draft, and what the tag and info being exposed is there. This should be fairly minor and isn't too contentious. In the architecture draft, we have a number of additional open issues. There's one about trying to figure out how much to discuss about malicious issuers in the ecosystem and what the architecture draft should say about that. If people have thoughts on the scope there, responding on that issue might be useful. There's some information about what to expose in terms of a server's configuration in the key commitment server configurations, and there's a balance between how much we specify in the architecture draft versus leaving it up to each individual use case and each individual application that's built on top of this. There's an open issue about centralization. There's a draft by Caden that I think might be currently expired that discusses the centralization issue. We should see whether we want to bring that into Privacy Pass or include it as part of the architecture draft. I think Mark's in the queue.
Yeah, Mark McFadden.
Thanks for noting that. That document has been updated. And the update was an attempt to try to describe what goes on in a redemption context, in the context of centralization. I think it'll be useful to work with Stephen to sort of talk that out. I think it needs to be a better section, but it has been updated to reflect the conversation we had at the last meeting.
Cool. So I think one question here is what we want to do to update the architecture draft to point at that doc, or what the relative status of these docs should be. And then there's an open issue about what we expose to proxied verifiers, which is one of the modes that runs in the architecture draft. I think just coming up with some threat model of what a proxied verifier should see versus the other constructions. And I think that's fairly straightforward. The other one is, once we've made all these updates, we should update the privacy calculations to take into account any discussion for the centralization doc, the redemption mode, and things like metadata, which we have a separate discussion about coming up. The other chunk of open issues is around supporting other constructions beyond just VOPRS. There's number 40, which is about public verifiability, which are tokens that can be verified without needing to be the issuer. And I think there are a few constructions that people have been talking about in that space. There's private metadata variants, which I think is going to be talking about the various metadata constructions as part of that discussion. And then there's the larger overhaul of how we should reformat the protocol to either abstract away the crypto schemes beneath it that Chris Woods has been writing up. This is PR number 79, and the general concept is adding an additional abstraction layer so that the protocol exposed by Privacy Pass is very generic and treats all the messages as arbitrary blobs, and any new construction we want to support defines its own internal functions and structures. And this should hopefully simplify some of the changes necessary on the high-level protocol. And makes adding these new constructions easier. It is a fairly radical shift from what is currently in the docs, so we probably want to see what people's thoughts on that are. Other updates are, we have a charter timeline that we came up with about a year ago, which is very out of date and has deadlines that we've missed. Mostly, we were hoping to get things done by February 2021, and then get some of the application layer things done in the summer. We'll probably want to update the charter timeline. One proposal is, based on the current status of the core protocol doc, trying to aim for IETF111 to get that cut with the VOPRF construction. Then updating the architecture draft based on the open issues that are currently there, and assuming there's not too many more open issues that show up, hopefully IETF113 would be a good timeline. And then the other two charter items pushed an IETF beyond that, since those build up on needing the architecture draft to be finished and the protocol to be semi-finalized, at least for the main construction. There's also a question of what additional constructions we want to be supporting in the working group beyond the VOPRF draft, or if we don't and want to leave that as a separate item. So the general open questions currently are whether we should do the refactor that Chris has proposed for the adding the abstraction, whether this updated charter timeline looks reasonable, or what would a reasonable charter timeline look like, and what metadata support should be in the draft, which we should discuss after Sophia's presentation.
Thank you, Stephen. Let's go to comments on those first two topics, and also on the status of Mark McFadden centralization draft. Ben?
Thanks. So I typed this in the chat, but I figured it might be worth asking since it's either one of the open questions. But whenever we're thinking about adding this abstraction layer to cover up many possible constructions that we could use to achieve the properties we want, there's always the risk that we get the abstraction wrong. And so I know we have quite a few things that were listed actually. We've got the VOPRF and we've got the blinding and BLS and whatnot. So it's pretty reasonable that we have enough potential constructions that we can analyze the abstraction. But that's sort of the big aspect of the open question there to me. And maybe Chris is going to answer.
Chris Wood?
Yeah, I can just reply to that. Yeah, basically the PR came from the observation that the abstraction was wrong as is. Trying to add a construction that supports public verifiability specifically based on the blind BLS or blind RSA signature scheme. It was incredibly difficult to take basically the wire format of that protocol and wrap it in the wire format for privacy pass. And so rather than try to have some generic wire format that somehow magically works for all the constructions that we might potentially see in the future, be it BLS, be it some Schnorr-based thing that potentially requires multiple rounds, what have you, it just seemed cleaner to sort of wrap all of it and sort of delegate the bits that are specific to the crypto construction and just have privacy pass be this very thin layer on top of those particular cryptographic protocols.
Right. So we would still need to make sure that we can handle those multiple round trips if some of the constructions.
Yeah. And I think that's the role sort of the wrapper that is privacy pass to be able to like deal with things that are multiple round trips or deal with things that have perhaps different contents therein. So the specific challenge with RSA versus VOPRF is that VOPRF in the response from the server during issuance, you get back a bunch of evaluated elements and then a proof, depending on whether or not it's like a batch proof or it's just like a single proof or a single evaluated element. But basically there's two things in that response, whereas in the RSA case, it's just like a single blinded signed message.
Right.
And yeah, so I think the proposal sort of captures the right abstraction, but it's currently just a draft. Certainly, people who have thoughts on what the abstraction should be should take a look. But I found that with this particular like RSA, like BLS, was a lot easier. So
it's promising.
That I hope is the sufficient rationale or reasoning as to why the PR exists.
Thanks.
Ben Schwartz, no chair hat. I have a question. Does this propose to add a document anywhere? Does this create a new document? Chris?
PR, you mean?
I mean this refactor, which defines a uniform abstraction here. Does this add a document to our set?
No. It just it just changes the existing protocol document.
Okay. And does it rely on a CFRG document to provide that abstraction?
Yes, but that is not new in the sense that the particular like the VOPRF construction and the VOPRF instantiation is already there.
Yeah, I guess in the current PR, the VRPF like internal like data structure is included as a separate section in the protocol document.
Yeah, that's right.
Okay. Is there anyone who wants to make a comment proposing an alternative or supporting an alternative to Chris Wood's proposal? It doesn't seem that anybody opposes your proposal. Does anybody want to speak about charter timelines? Chris Patton.
Is the consensus that we'll move forward with Chris's proposal?
So as chair, I would say it's not clear to me that this is something that needs working group consensus for this change. It seems to me that this is in the hands of the editors, and as long as they, as long as there's no conflicting input, I think the editors can proceed as they wish. To be honest, I'm not sure what the procedure is for updating a charter timeline, but I will ask my co-chair and maybe our AD, and we'll think about that. It seems like if there's no other comments, we should move to the next segment.
I guess I have to put in right?
We did have an agenda bash, so I believe the next segment will be about metadata.
Chris, were you going to present about metadata, or was Sophia? Or
I believe that's Sophie's presentation.
Okay. Should I start presenting?
Yeah, if you want to present, that's fine. If not, I can present either way.
Okay. There's no slides available here. Could you share the slides yourself and I ask you to move them? Thank you. Okay, I'm just going to be waiting until they show up for me. Okay. I think that's good enough. And then if you scroll, that would be perfect. Okay. Okay, so hi everyone, my name is Sophia Selly and I'm a cryptography researcher at Cloudflare. And today I was going to talk about how to add a proposal on how to add public metadata to PrivacyPass. And if you want to actually take a more in-depth look at this proposal, there's already a PR against the base traps. So if you want to check it out, please do so in that link. Next slide, please. Okay, so basically what is the proposal, as I said in the title of the presentation, is to add public metadata into the current, as it is right now, currently defined PrivacyPass. And this proposal is built up in a paper that we published recently to the ePrint. My co-authors are listed in this slide, and you can find it in that link if you're interested in reading more about it. Of course, there have been already other proposals that have been either proposed on these sessions or can be found in the regular places. There has been one proposal about how to add private metadata bit that can be found at place. Another one that came from Facebook on how to add public metadata by using a different construction that is called an attribute-based BOPRFs. Just to note again, this construction that I'm going to be presenting today deals with public metadata, not with private metadata. Next slide, please. Okay, so the question is, why should we add metadata? Specifically, why should we add the public metadata? The reason is because, at least in this, the specificities of this construction that I'm presenting, is because it is useful against certain attacks. Something that has been noted early on since the early paper PrivacyPass is this idea that one can execute a holding attack against the protocol. In the first paper PrivacyPass by Goldberg et al. Is actually defined as a farming attack, and I think it is defined on section 8, if I'm not wrong. But it's basically the same attack that I'm talking about in this slide. The idea that individual users, individual clients, or a group of clients can gather tokens over a long period of time, and then they try to redeem them all at once. And the reason why attackers might want a malicious client, a malicious user, an attacker would like to do this is because they want to render the service unavailable. So the idea is, so one of the things that in the original privacy paper says that there's ways to actually preventing this. The mechanism to preventing this are several. One of them is to only have an X amount of tokens that can be issued at certain amount of times. Another prevention that they listed is to add this idea of a key rotation, in which that even if an attacker is able to gather a lot of tokens for an X amount of time, they will not be able to redeem them all at once in a different time because the key under which those tokens were issued has been rotated. But of course, it has also these problems because if you are rotating the key all of the time with a specificity that is too short, then you will be diminishing the anonymity of those tokens. So we thought of a new construction that will be much easier to implement than just having this key rotation mechanism, and that is the idea of adding public metadata. And the way to solve the hoarding attacks problems is by adding certain metadata that prevents against this. The metadata that you can be adding is, for example, an expiration times to the token, or you can also be adding a geographic location to the tokens. And in the last slides, I'm going to be talking about specifically what the specific metadata you could be adding, because adding metadata to the construction as PrivacyPass has to be always carefully considered, because you could be diminishing the anonymity set. Next slide, please. So as we know right now, as it is right now written in the PrivacyPass document, the underlying primitive that is used is a BOPRF. That is the one defined here that we all know a lot, and that is basically that two parties want to compute a pseudo-random function that has the obliviousness property. And what does this obliviousness property means is that the secret key of the server remains secret, and the input that the client inputs in the function also remains secret, but both can compute the output of the pseudo-random function. The idea of adding public metadata is really simple. As you see, the construction only get added one parameter that is well known by the client and the server. And most of the operations at that line are really a change, but are just the changes are really little. And if you want to know more about what changes it requires to the BOPRF construction, there's also already a PR open against the CFRG draft that you can check out. At the end of the presentation of the slides, I actually have the link if you're interested in following that. Next slide, please. Okay, from a PrivacyPass perspective, as we know, PrivacyPass has two phases, which is the issuance phase and the redemption phase. And here, as you see in the construction itself, the only thing that needs to get added is the client metadata and the server metadata. And in this case, these are values that are publicly known by both and that can be actually defined prior to the execution of the protocol, or can also be sent during execution by the client on the server. And that's a decision that is kind of outside of the protocol, is how applications want to define what metadata will be added. That to the issuance, as the CNU issuance is not really part of any of the commitment phase, but actually in the issuance phase of the issuance phase. Next slide, please. For a redemption, it is the same. You're going to be assuming that the client and the server know what metadata they're going to be adding that is publicly known, and they will be adding to all of the API BOPRF functionality that meets it. Next slide, please. Okay, as I said, nodes of metadata. Even though this construction allows you to add a public metadata that is known by the client and the server or both, it has to be carefully considered, because any kind of metadata that you're going to be adding, it will be diminishing the anonymity set. So for example, in the case of actually trying to prevent these hoarding attacks, you can be adding expiration time of the tokens, but this expiration time should not be explicit, because if you're actually saying that this token is only valid was issued during this time and is valid until this time, you will be diminishing quite heavily the anonymity set. Right now in the current PR, you will see that we are not using explicit timestamp, but we're actually using epoch numbers, meaning, for example, the survey defines that the epoch is since today until 2 months and calls this epoch a number, let's say 1. And then they add this one to the token, and that's the public metadata that is known. And therefore, the anonymity set gets diminished, but not as heavily as it will be if you're using explicit timestamp. Yeah, another note to have is, of course, is that this metadata that you're adding to the tokens is not bounded by length. You can add as much bits of metadata that you want as possible, but it has to be carefully considered by the application itself, because obviously added metadata that's really, really big will not be really useful for applications. So this is application dependence to balance privacy and utility. And as I said, if you want to check how this construction impacts the VOPRF construction, there's already the PR that you can find here. And also, if you want to see how it has been added or what thinking there has been to be added to the privacy pass draft, that's the PR. And I think that's my last slide. So next slide, please. Okay, yes, thank you. And I'm open for questions. I see that there's already Jabber discussion. Okay, Christopher, you go. Sorry, should I call the people? Okay, wait.
Chris Patton, you're on the air.
What was the name of the second paper? So you listed some alternatives. There was the Facebook paper, and then there was one other paper.
So the other paper is not about public metadata, it's about private metadata. So it's called something like adding a private metadata bit, and it's by Tancred Lepoint et al. Yeah.
Could you just put up the slide so I can write it down? Thank you.
Yes, second slide, I think it is. Yes, that one.
Any other comments on the adding public metadata, or you know, whether it's a good idea in general?
Chris Wood?
Yeah, I think it's a good idea, but I think the larger question is whether or not it's something that constrains all instantiations of Privacy Pass or only applies to certain constructions. So would it be desirable to ship Privacy Pass such that you could use just the VOPRF version without any metadata support, or must it be the case that any version of Privacy Pass supports metadata? Because that drastically changes what's possible underneath the hood. Right now, we only know of one sort of construction that works for partially oblivious PRF support, the one that's listed here on the slide. And we have sort of ideas as to how to clutch things together, glue things together for publicly verifiable or partially blind signatures. But that's still very much sort of an open research question. And if requiring metadata for all instantiations was going to be the way we went, that might delay sort of that public verifiability extension. So curious to hear what people think about that.
Yeah, thank
Steven?
you, Chris. Curious as
sorry.
well. Oh, sorry, you go, Steven.
As responding to that, yeah, I think like requiring every construction to support private or support metadata at all, like, seems like maybe a high bar, and like there might be use cases where we don't need like all this extra like infrastructure. I think there's also the question of like how much the documents should talk about like metadata as an abstract concept versus like specifically like it's used for epochs and other things like that.
Yeah, I completely agree, Steven. Right now, as it is in the PR, we only define geography, localization, and the timing. And it's kind of open if someone else wants to add anything else. but might be worth revisiting that. Against the optionality of adding or not adding public metadata, as right now how we're writing for the CFRG draft, which I didn't cover today, and if you want to see that talk, that's coming later today. There's the possibility of you adding an empty string and it will still be working. But yeah, there could be other construction besides the PPRF one that allow you to use metadata, and that's like a big API discussion as well.
Yeah, so thinking about whether to make the metadata mandatory, I think making arbitrary metadata mandatory would certainly be, I think that would be a high bar. Maybe these specific cases that you have listed could be accommodated, but I kind of think we might have to dig in and see how critical those features are. But if they're not super critical, then I would say it'd be better not to have that requirement.
Chris Wood?
My take regarding the sort of generality of the metadata is that if we're going to sort of support it, I don't think it should be bound at the protocol layer. We can certainly give examples of what are suitable uses of metadata, like epics, like geo stuff, whatever. But it seems up to the application to determine exactly how many bits they want to admit, if any at all. But that's my 2 cents.
Alex?
Hi, I was wondering if this partially oblivious PRF supports like no metadata bits, and the reason I ask that is kind of wondering whether this construction could just be used instead of the original VOPRF, because as far as I know, the performance seems pretty similar.
Yes, thank you very much for that question, Alex. So right now, for example, in the PR that we have for CFRG, there's the possibility of you not adding any metadata at all. And in that case, what happens is that you just add a context string plus some empty string, and that's all. Because the underlying operations of the POPRF execute almost as efficiently as a regular VOPRF. So yeah, so it's completely fine if you pass an empty string, or if you pass an actual metadata string.
Hi, this is Ben Schwartz as individual. I wonder if you could share your thoughts on the trade-offs or the relationship between public metadata in the construction versus having a larger number of issuer keys with metadata associated with the issuer key.
So what you're talking about is the difference between having different keys for key rotations compared with adding metadata?
Not for key rotations necessarily, but so there's a sort of a trivial way of adding metadata where we simply assign each metadata value to a distinct issuer key.
Yeah, I think that was more like the PPRF construction. I think it was that one. The problem with that construction is that it's not as efficient actually as the PPRF one. You need to add a zero knowledge proof that executes much less efficiently. And that's what was much more likely the problem with that construction. So actually adding the PPRF one is kind of better in comparison how you will add public metadata, because it's much more efficient.
Efficient in, sorry, just efficient in what?
Computation time. Yeah.
Okay.
Specifically in the ABPRF construction, it's because the zero knowledge proof that you have to be adding for the verification part is less efficient.
Okay, thank you. Chris Wood?
Yeah, Ben, I just wanted to ask a clarifying question to you, actually. Was your question about the naive metadata approach where you have like a single signing key for each value of metadata, or were you asking
That's-
specifically in the context of the attribute-based VOPRF construction?
Yes, I was not really asking about the attribute-based construction. I was thinking about the very naive one key per value construction.
Gotcha. So I think Sophie's answer was great for the attribute-based one, and she probably has thoughts on the other one as well, so I'll let her take that.
No, I haven't done much thoughts, but I think that we'll need a little bit more careful analysis. That will be my answer. That maybe that's something that I can start looking at for later. Yes.
Okay, thank you. Stephen?
Kind of are doing that in the like trust token experiments. And I think the big issue is like it works fine for like small amount of metadata, like 2 or 3, but like all clients are going to need to know like the full set of like applicable keys, which then like balloons up to like hundreds of points if you're like doing any like significant amount of metadata. And it also means you can't like do arbitrary named metadata and have to know a priority like what it is.
Thank you.
Yes, thank you, Steven. Yeah, that's great. Thank you. Sorry for forgetting about that one. Thank you, Steven.
Chris Patton?
Do we have any use cases right now that involve more than just a few bits of metadata?
No, as it is right now, of course, if you would like to really add the whole time expiration time is really split in a really explicit way, I don't recommend doing that. I don't think we should recommend doing that, but you can use it. But what I personally think is that the metadata that gets added publicly should also be small enough, because that will also, what I think is that that will not be diminishing the anonymity set so heavily, because if you add things that are more explicit and maybe bigger, then maybe you will be harming the anonymity set further. It kind of more depends on, yes, you can add as much as metadata as you want, but the biggest concern with adding metadata is the anonymity set rather than more like if it's okay to add a lot of metadata.
So, Sophia, I wonder what your recommendation is to the working group. Would you recommend that we add a public metadata element to the Privacy Pass API?
Yes, I do recommend that. But I would really like to know also the thoughts of the CFRG happening later today, of adding easily adding the BOPRF construction into the BOPRF one, because the Privacy Pass builds on top of that draft. So I would like to know if indeed that's something to be supported there, because then it's much more easy to also modify the draft, to do recommendation of the draft if the underlying primitive is also part of the CFRG one. So I would like to know the output of that discussion as well.
Great, thank you. I think we're ready to move to the next segment.
Are you presenting again?
Oh yeah, I'll present again.
Okay.
So really briefly, there was an anonymous credential meeting that happened a few weeks ago at PETS 2021, and we'll go over some of the Privacy Pass relevant things that came out of that meeting. So one of the main things that came up there were a couple of presentations about various anonymous credential constructions. There was one by Alex about post-quantum construction, which is an extension of the OPREF scheme to use a lattice-based approach. And this might be interesting if Privacy Pass is concerned about more post-quantum proofness. There were also some of the constructions that Sophia mentioned regarding adding metadata in various forms beyond just the like naive one key per metadata value, which if we think that having lots of different metadata values might be worth investigating more. There were also a lot of discussion about various use cases, some of them which might be applicable to Privacy Pass. The ones that came up were contact tracing and anonymous credentials. And notably, the one thing that those use cases sort of require that is only like partially supported in current Privacy Pass, but would maybe be more supported with the addition of metadata is having non-identifying information in these tokens, or so that like you can limit like the domain they're used in a way that like the client is like aware of what the metadata is and it can like make a informed choice that it's not like your username or your real name or anything identifying. There's also the requirement for some sort of time-bounded or one-time use time-bounded tokens that like expire at a certain amount of time after being used, which you can sort of use in Privacy Pass by having very short key rotations, but that adds logistical complexity, and the additional key rotations also have some amount of privacy implications in terms of different users having different expired tokens. And having a like nicer way of supporting that might support those sorts of use cases. More generally, these anonymous credential meetings been happening about twice a year and is been a good place to get these sorts of use cases and discussion about additional constructions, and they'll hopefully keep on providing some useful fodder for Privacy Pass to think about and for constructions to happen here. I think the next one's in January, hopefully around real crypto time. And it might be a good idea once Privacy Pass is further finalized to see whether the charter or Privacy Pass should expand to include some of these use cases, or there are separate work streams that should be spun up in regards to anonymous credentials. Yep.
With respect to some of those additional use cases, how would the addition of metadata solve some of the, or how many of those, or is it?
So I think the addition of metadata could solve some where like the information required isn't identifying like, but I think like we'd need some sort of brand new construction for anything that's like a time-bounded token, where like the time bound is based on when the token was issued, but in a way that like isn't like you can now split it by like the exact issuance time. There might be ideas of like splitting up the like chunking time to do something similar to the epoch stuff that Sophia mentioned. So I do think like adding metadata does add support for some of the use cases. There are some that I think will still be beyond Privacy Pass with metadata without additional work.
Okay, thanks. Any other comments on that particular presentation? If not, I think we have run through our scheduled agenda. I know there's been some discussion in the chat on whether to add on the abstraction layer that's been proposed. I don't know if we have some time that we can continue that discussion here, or if not, we can all get ready for CFRG.
So I think that one part that came up in the chat that I think Martin Thompson raised was sort of the question of, do we need to support the VOPRF style at all versus going straight to publicly verifiable, blind signatures type thing? Because the charter is treating the public verification as an extension that we'll do as a follow-on. But in some ways, the protocol is actually simpler if you do it that way, versus the VOPRF being a little bit more efficient, I think, if I'm remembering the chat correctly. So that might be a topic to discuss live as well if people have further thoughts. But to be clear, I don't have particular thoughts myself.
Chris Wood?
Yeah, I mean, it's an interesting proposal. I guess my question would be, imagine you did that and you abandoned VOPRF and you just said, we're going to do something like, partially blind signature. What is the difference then between, a protocol that is a partially blind signature and Privacy Pass? Like, what is the thing that Privacy Pass adds on top of that is not already provided by the underlying protocol? It's not clear to me that there is anything sort of noteworthy there. So if we just sort of reduce this all down to one primitive, sorry, I'm clearly holding this wrong. If we reduce this all down to one primitive, it's not clear to me that we have sort of a useful protocol at the end. But there are other people in the queue.
Alex Davidson?
Yeah, I guess my thoughts on the matter are that I think that there are applications where the efficiency advantages of using like the symmetric VOPRF will become apparent. But I think on that note, as much as finding applications where like public metadata is going to be useful for us, I think also finding applications where using like a symmetric VOPRF with no metadata would also be useful in order to ascertain whether we really do need like that stripped back construction.
Martin Thompson?
Because it seemed to me like the VOPRF wasn't adding anything, but someone just said optimization, and that creates a visceral reaction in me that says, well, maybe you just need a better whatever the primitive is. At the same time, I think I'm coming around to the view that we probably have some value to add in terms of tying down parameters and defining maybe formats closer, more close to how HPKE does its work and say TLS does its work. And in that context, yeah, it does make a bit of sense to have a bit of choice in how you implement things.
As individual, Ben Schwartz, I was under the impression that the VOPRF schemes that lack public verifiability have stronger cryptographic security proofs, or are proven secure under stronger assumptions. I wonder if one of the crypto experts could shed some light on that. Alex?
Yeah, in a sense that's true. But I think the main points are that the publicly verifiable schemes that we know of are currently based on either pairings or RSA, and I think the main point is that choosing parameters in such a way that the security assumptions remain secure in those settings is slightly more difficult. In the RSA setting, obviously you have to choose things so that the RSA assumption is secure, and in the pairing setting, I think security is just a little bit less known because it's slightly newer cryptography, and you do see generally more cryptanalysis in that area, so security parameters can change. So in that sense, you would have more confidence in the classic prime order group setting that the original VOPRFs are kind of based in.
Thank you, Alex. Chris Patton?
Just for the record, I didn't get that all. Which class of protocols require stronger assumptions? than which class of protocols, at least right now.
Alex, could you give that summary for Chris, or
Yeah,
adjust your
so-
notes in the?
So the VOP, the original VOPRF, like the 2#DH VOPRF that we used, is based on like a one more gap Diffie-Hellman assumption.
Gotcha.
The partially oblivious pseudo-random function, I believe, is based on a variant of like a Q-strong Diffie-Hellman assumption. And then I'm less well versed. Blind RSA, I guess, is based on the RSA assumption, and the pairing-based assumptions, I'm not actually very well versed on what assumptions they're based on, but I assume it's some bilinear variant of like a discrete log type assumption.
And we know, like, we know the relationship between the Diffie-Hellman assumptions, and then the RSA assumption is super standard, and then the pairing-based scheme, we don't know in this room.
That's my take.
Okay, thank you.
Martin Thompson.
Basically with chicken. What I'm hearing here is that we have a bunch of primitives, and each one of them has some sort of subset of the various capabilities that we're looking for, whether it contains public metadata, private metadata, and public verifiability or not. And none of them seem to provide all of those capabilities yet. Each one of them has different performance characteristics. Each one of them relies on different security assumptions. And we're sort of in a CFRG mode where we're going to be trying to pick the right primitive. That makes me worried about this work, quite frankly. I don't know how to deal with that situation very well because, yeah, this sounds more like research than it does engineering.
Thank you, Martin. Chris Wood.
Just to react to that, it's definitely true that the different primitives have different feature sets. Like some of them are publicly verifiable, some are not. I'm not sure. One of the assumptions I have been making, perhaps implicitly, is like all the constructions that we're considering, we consider them to be at least as secure as one another for some definition of secure. That is to say, people who are deciding to choose one variant of privacy pass or the next, or the other, one variant over the other, should not have to make a determination in terms of like what type of security they want. That just seems kind of terrible. Like the TLS 1.3 did a very good thing in that, like, okay, well, for AADs, we're just going to pick 3 AADs that we know have basically the same properties, and the choice doesn't really matter. It comes down to performance. You do you, whatever you want. Ideally, we'd be in a similar posture here, wherein the differences in the primitives or the instantiations rather vary only in what features they provide and possibly also performance. If we can come up with a scheme that makes the performance question moot, even better. Yeah, Sophie.
Thank you. Sophia Selly.
Okay. Yes, I want to agree with Chris Wood in the sense that, yeah, all of the constructions that have been proposed are targeting almost the same security properties. It is true that they are based on different underlying assumptions, but at least also when you're trying to add an extra feature, most of the times when adding this extra feature is adding already onto the well-known primitives. So for example, in the POPRF's case, one of the big focus of that research was to actually provide the same properties that the BOPRF was. So I don't think that the BOPRF has. So I don't think it's just that, because that would be really bad for any user reading this. I think they all are targeting kind of the same security properties.
Thank you, Martin.
My point for me. I don't think it matters what security assumptions we're basing these things on, as both of you have established. But that's not the focus of the comment. When we do engineering, typically we try to choose the one tool that's going to work for the use cases that we have. What it sounds like we're doing here is we're trying to get all the tools for all the use cases. And that makes me very nervous because I don't want to get into some sort of open-ended thing that says, well, we're just going to do something and everyone's going to do their own thing. That's not actually seeking interoperability. That's everyone doing their own thing. They just happen to be talking at each other at the IETF. That's not really a constructive use of the time that we have here.
Okay, well, I hope our document authors are inspired by these comments to update the documents and bring back to the working group new revisions that address these inputs from the group. Joe, over to you for any last comments.
That's all I have. Yep. Hopefully, see a bunch of activity in the drafts and on the list. And we'll see you next time, or in CFRG if you're going there.